Hi all, this is lecture 6 on quadratic equations. So we are going to jump right in here. We are now going to try to solve quadratic equations. So the definition for a quadratic equation is an equation with constants where a is not 0, b and c, and variable x that is written the following way. So we would have an a x squared plus bx plus c is set equal to 0. Now it doesn't have to look like this, but it should be able to be put into this format. And you can see that if that a is 0, then the x squared goes away, and we're working with the same linear equations we were in the first section. So that's why we want the a to not be 0, okay? Now, there are 4 ways to go ahead and solve a quadratic equation. The first one is factoring. Number 2 is solve using square roots. Number 3 is complete the square, and 4 is the quadratic formula. Okay. Now, most commonly, you're going to use factoring and the quadratic formula, but it is good to know all 4 ways. So let's go through them. So the first one is to factor. And so we've got an example here, x squared minus 5x equals -6. And when you factor, you always want to set this equal to 0. So in my example here, I'm going to go ahead and add 6 to both sides. And that's going to give me x squared minus 5x plus 6 is equal to 0. So I always want to start by doing whatever algebra steps I need in order to set this equal to 0. From there, we're going to factor the quadratic on this side, okay? Now, if there's no 1 out front, we factor like normal. If there is a number in front of the x squared, we're going to go use our box and circle. In this case, I'm looking for 2 numbers that are going to multiply to 6, but add to -5. And I think -2 and -3 will do it. So I believe that we can make this x minus 2 and x minus 3 equals 0. Okay, so that's what we did in the last section. Once you have it factored, you're going to set each factor equal to 0 and solve for x. So that means I'm going to take this one, the x minus 2, and set that equal to 0. And I'm going to solve. So I'm going to add 2 to both sides. And that's going to give me x equals 2. Then I'm going to take the other factor, x minus 3, and I'm going to set that equal to 0. And go ahead and add 3 to both sides so that I get x equals 3. Now, why does it make sense that I can do that? Well, if you think about it, you have 2 things that are being multiplied together here, right? You have thing 1 and thing 2, okay? And when you multiply them, you have to get 0. Well, the only way you can multiply 2 things that are 0 and get 0 is if one of them is 0. So either the first one has to be 0, which means that 2 is going to give me a 0, or the second one is 0. So one of those 2 has to be 0 in order to get the 0. So we take each piece and set it equal to 0. Okay, and then we solve. So I should get x equals 2 and x equals 3. And you can go ahead and plug back into the original and see if that actually works. And they should. Okay, so that's factoring. The next one is to solve using square roots. Now this one, you're going to notice is in a kind of like a special format. So I only use this technique if it's already written this way. So you'll notice that I only have one x here, and it's in parentheses, and my square is on the outside of the parentheses. And everything else is just a number. That's going to allow me to go ahead and just solve for x. Okay, I'm going to have to use square roots and plus minuses, but I can just solve for x. So I want to uncover my x. Now what I don't have to do here is this is the only one where you don't want to set it equal to 0. Okay, I want to leave it just as is. So I'm going to leave it just the way it's written. So I'm going to leave it as 2 times x minus 3 squared plus 1 equals 3. And then I'm going to go ahead and solve this by removing things one at a time. So I'm going to subtract 1 from both sides. So that's going to give me 2 times x minus 3 quantity squared equals 2. Then the next thing that's furthest away from my x is this 2. So let's divide both sides by 2. That's going to give me x minus 3 squared equals 1. Okay, now the next thing I want to get rid of is this square on the outside. In order to do that, I can take the square root of both sides, but I have to remember that when you take the square root of a number, you can get a positive answer or you can get a negative. So we need both. So we can take the square root here and the square root here, but we got to remember our plus minus, okay? So on the left, I'm left with just the x minus 3 inside, and over here, the square root of 1 is 1, so I get plus or minus 1, okay? Then I'm going to go ahead and add 3 to both sides. And so what I have is I have x is equal to 3 plus or minus 1. Well, if I read the top, 3 plus 1, that gives me x equals 4. And if I read the bottom, 3 minus 1, that gives me 2. And so those are my two answers. Typically, if we're going to have answers, we get 2 of them for a quadratic because it's squared. We get 4 and 2. Okay. Now, if you remember, if you go to take a square root here and you have a negative number, you're going to get answers that are imaginary. We can still write them down, but they are imaginary. They are not real solutions that you can graph on the real line. Okay. So when it's set up like that and already squared, we can go ahead and solve it in that way. Okay. Option number 3 is to complete the square. So the first thing we're going to do is we're going to set this equal to the constant term. So I want only things with x's on the left and only constant numbers on the right. So I'm going to go ahead and add this 8 to both sides. And that's going to give me 3x squared plus 12x equals 8. Then I'm going to go ahead and divide through by a because I want to get rid of this number right here. So I'm going to divide everything by 3. And when I do that, I'm going to get x squared plus 4x equals 8 over 3. Okay. And now here's the part where we're going to complete the square. So what I want to do is ideally my goal is to make this look like something squared, right? So in order to do that, let's think about what those squares look like for a second. So if you take x minus 3 and square it, we've done this quite a few times, we square the first term to x squared, we square the last term to 9, and the middle term is the 2 multiplied and doubled. So it's negative 6x plus 9. One more, let's do x plus 4 and square it. We would get x squared plus 8x plus 16. So what we want to do is say, okay, if I know what this number is, how do I determine what this number is? Okay, and if you notice, it all relates back to this 3 right here, right? So the yellow term here is that number doubled, and the end number in blue is that number squared. So if I'm starting with the yellow number, I would have to divide by 2 to get back to negative 3, and then I would have to square it to get the 9. So we're going to add the appropriate constant term to both sides. The appropriate term there is half of b and then square it. So for this one, I'm looking at the 4x, and I'm going to take half of 4x to get 2x and square the 2. I'm only looking at the number part. So take 4 over 2, which is 2, square it to get 4. And I'm going to add it to both sides. So I'm going to have x squared plus 4x plus 4 is equal to 8/3 plus 4. Okay. Then I'm going to go ahead and factor that left side. I'm going to make this x plus 2 squared. Okay, you can use your box and circle or what 2 numbers that multiply to 4 and add to 4, however you'd like to see that. And then over here on the right, I'm going to go ahead and combine those two. So 8/3 plus 4 becomes 8/3 plus 12/3, so that is 20 over 3. Okay. And then we're going to solve as if this were the square root problem from before. So I'm going to go ahead and take the square root of both sides. So that's going to give me x plus 2 on the left and plus or minus the square root of 20 over 3 on the right. And then I'm going to go ahead and subtract that too. And so we get x equals, and let's make sure it's on both sides, the negative 2 plus or minus the square root of 20 over 3. And that I can leave as my final answer. Okay, because that's real answers. There's 2 of them because it's plus and minus. Now, if the square, what was under the square root was a perfect square, we could go ahead and figure that what that is and list out our 2 numbers, or we could use a calculator to find the decimal equivalents. But we're going to leave it just as that. Okay. And lastly is the quadratic formula. And essentially, if we take that generic form that I showed you up above and we apply the strategy of complete the square, we're going to end up with what you usually know as the quadratic formula. So I'm going to go ahead and throw it once for you. The first thing I'm going to do is I'm going to go ahead and I'm going to divide through by a. Or actually, let's not do that. Let's do what we did before. So let's move the c to the other side. We move the constant over. That will give me ax squared plus bx equals negative c. Okay. Next, we're going to divide by a on both sides. That's going to give me x squared plus b over a times x equals negative c over a. Okay. Now, I need to add in the appropriate term on both sides. So I want x squared plus b over a, x plus something, negative c over a plus that same something. Okay. And remember how I get it. I take the number that's in front of the x. So this b over a. I take half, or divide it by 2, either way, take half, and square it. So half of that would be b over 2a, and then I would need to square it. And we're going to add that to both sides. Okay. What that does is it means that you end up with x plus b over 2a squared on the left. Okay, just trust me on that one. You can kind of check it because this is the square root of this one right here, right? Okay, on the right, let's do a little bit of work here to simplify this. So negative c over a plus, if we square that, that becomes b squared over 4a squared. Okay, now in order to add two things, I need common denominators. So I need to multiply this one by 4a, top and bottom. That way I have negative 4ac over 4a squared and b squared over 4a squared. And now I can add across the top, and we're going to put the b squared first because it's positive, minus the 4ac all over 4a squared. Okay. Now we're back over here and we want to solve for this. We're going to get rid of that square by taking the square root. And we get x plus b over 2a equals, now we need a plus or minus here, the square root of b squared minus 4ac. So b squared minus 4ac is not a perfect square, so I'm going to leave it under my square root. But on the bottom, 4a squared is a perfect square, so it can come out of the square root as a 2a, right? You got to take the square root of it. And then lastly, we can go ahead and subtract that b over 2a from both sides. And that allows you to arrive at what you know as the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a, right? I can put those together because they have the same denominator. Okay, and that is our quadratic formula. Okay, so this is your quadratic formula. I would put that on your note card if you're not already familiar. Okay. So we're going to apply that to this one, right? So the first thing we're going to do is set equal to 0. And the nice thing about this example right here is that it's already set equal to 0. So 2x squared minus 4x plus 1 equals 0 is already ready to go. Then I need to identify my a, b, and c. Now don't forget to take the sign with you. So my a is the number sitting in front of the x squared, so that's a 2. My b is what's in front of the x, so that's a negative 4. And my c is the constant term, which is 1. And I'm going to go ahead and plug that into that formula. So that means, be careful a little bit here, negative b is the opposite of b. Right now I have negative 4, so the opposite of b would be positive 4. Plus or minus, negative 4 squared is 16, goes under the square root. Minus 4 times 2 times 1. All over 2 times a, and 2 times 2 would be 4. And then we're going to simplify as best we can. So we're going to have 4 plus or minus the square root of. 4 times 2 times 1 is going to be 8. 16 minus 8 is 8. All over 4. And then typically what we do is we try to pull any square roots out of that 8. So this is 4 plus or minus 2 root 2, right? And that's because the square root of 8 is the square root of 4 times the square root of 2, and the square root of 4 is 2. Okay, all over 4. And there's not a 4 in each place, but I can cancel a 2 in each spot. So this, in the simplified version, is 2 plus or minus root 2 all over 2. Okay, so that's what it will look like. All right, now the last thing we want to talk about is what types of answers that you could get. So if we take a look at this one, let's see. This one, I'm going to try to factor because I think that this is doable. So if we factor, I'm going to use my box because there's an a is 2 here. So 2x squared and negative 3 means that a negative 6 is in my box, and I need to make positive 1. So 3 and negative 2 will work. So 3x and negative 2x. In the top row, there's a 2x in common. And when you take it out, there's an x, and a minus 1. In the bottom row, there's a common 3, and when you take that out, it works. So this becomes 2x plus 3 times x minus 1 equals 0. And then I pull out each piece. So the 2x plus 3 becomes 2x plus 3 equals 0. Subtract the 3 to get 2x equals negative 3, and divide by 2 to get negative 3 over 2. Then this one over here, you're going to say x minus 1 equal to 0 and add the 1 to both sides to get x equals 1. Okay, so we do get 2 distinct answers. So 2 real answers. Okay, that's an option. In the next one, okay, I'm going to go ahead and let's try factoring this one as well. So let's set it equal to 0. So let's add the 36 to both sides. That's going to give me x squared minus 12x plus 36. And I'm looking for two numbers that multiply to 36 but add to negative 12. And I think 2 negative 6's will do it. So x equals minus 6 and x minus 6 equals 0. And when you take each of these, this x minus 6 equals 0, add 6 to both sides will give you x equals 0. And this x minus 6 will also give you x equals 6 as an answer. And so in this case, there is one real repeated solution. Okay. And in our last one down here, I've got factors of 1 that add to 1. I don't think that's going to work. So let's try our quadratic formula on this one. So that means my a is 1, my b is 1, and my c is 1. So if I do that, that's x equals negative b, so negative 1, plus or minus the square root of b squared, so 1 squared is 1, minus 4 times a times c. So a and c are both 1, so 4 times 1 is going to give me 4. All over 2a, which is 2 times 1, so 2. And that's going to give me a negative 3 under the square root. And what happens is we can't take the square root of a negative number. And so what we do, we let I equal the square root of negative 1. And that way we can write this as negative 1 plus or minus I root 3 over 2. And this is what we call two imaginary solutions. Okay, so there are 3 things that are possible anytime you solve a quadratic. You can get 2 real answers, 1 repeated real solution, or 2 imaginary solutions. That's the only way it can happen. And the thing that will tell you what you're going to get is called the discriminant. And it actually comes from the quadratic formula. So if you look at the square root of b squared minus 4ac, right, that's a part of the quadratic formula. If the b squared minus 4ac is less than 0, right, it's negative, then this is the 2 imaginary solutions like we had down below. If this turns out to be 0, then what's underneath the square root is 0, and you're adding and subtracting 0, which means you're going to get 1 repeated solution. And if this is positive, then you're going to get 2 real roots, or 2 real solutions. So what is underneath the square root in your quadratic formula is what's going to determine what type of solutions or how many that you're going to get. Okay. We're going to table this here, and then we'll get into guided practice with lots of examples.